Good afternoon, everyone. My name is John Reitman from TurfNet, and welcome to today's TurfNet University webinar. I'll be your host today. Our guest is Dr. AJ Patton from Purdue University, and he is going to be talking to you about adjuvant use and getting the most from those. We'll be on here for about an hour or so today. If you have any questions for Dr. Patton, please go ahead and pop those into your question box there, and we'll answer as many as we can. I want to quickly thank our sponsors, BASF and Grigg Brothers, for their support of our online education. Dr. Patton does have some handouts that we're going to share with you today, including a PDF, I believe, version of today's presentation. So we'll be popping those into your handout folder, and I think you'll get some sort of a prompt when those come in and are available to you, and I think you can just open them up and then download them from there. So without any further delay, we'll turn things over to Dr. Patton, and everybody, hope you enjoyed today's presentation.
Okay, thanks, John. So you'll have to bear with me today. I'm suffering from some allergies, so my voice may crack or seem a little weak at times, but I'll try to speak up, and hopefully y'all can hear me okay. So today we're going to talk about adjuvants, and it's a complex topic, and we're really just going to give an overview today, if you will, and there's a lot of unanswered questions, but I hope to give you a little bit more information on adjuvants and help you with some of your decision making regarding whether or not to use them and when to use them to maximize your application efficacy. I'm not a chemist, although I did take several chemistry courses, and I don't tell good jokes, which it works out okay since this isn't a in-person presentation anyways, but I do try with my job very much so to just give you all the factual information so you can make decisions on things. So I'm going to share some information about specific products today, but not trying to recommend any of those per se, just tell you the factual information I know about those products and how adjuvants may or may not be influencing their effectiveness. So we'll go ahead and jump into the content today. And as I mentioned, there's a lot we don't know about adjuvants. They're much less research than pesticides and fertilizers and PGRs that we use in the turf industry. And so for that reason, we just know a little bit less about them than these other products. But your spray tank water and these adjuvants you use can have an influence on the efficacy of the product. And so I'm trying to do more research in this area because I know it's an area that we just lack some information. So a lot of what I might share to you today is information that we've learned from other crops besides turf, but we can take what we've learned in these other crops and apply it to turf. But we do have quite a bit of turf-specific information as well. So we're going to talk about water quality and the factors that affect pesticide performance, because most of these adjuvants are related to some kind of a response to the water that you're mixing these products with. And we're going to learn how to correct any issues we might have with water quality if they're problematic for you. And then we're going to learn how you can maximize the efficacy of these other products with these adjuvants, just so you get the best results and you maximize those dollars that you're spending at your golf course. So feel free to ask questions. We've got the box there down in the bottom where you can type those in, and I'll do my best to answer those as they come up. Now, there are really two things we need to talk about today. We need to talk about the pesticides and we talk about the water. And I'm just going to use pesticides here, but we could probably a better term maybe products. We know the most about how adjuvants might affect pesticides. We have very little information on how adjuvants might affect fertilizers or how they might even affect PGRs and some of the other products that we use. So most of what we know about adjuvants is how they affect herbicides and insecticides and fungicides. And we know these pesticides are formulated in many different ways. So we have, dry products, liquid products. In the liquid products, we have encapsulated products and soluble products and flowable products and suspended products, and so we have all kinds of different formulations, and that does influence which adjuvant we might choose and how these products are made by the manufacturer. And adding adjuvants, we know in some cases can improve the performance of these products. There's many adjuvants, and we're going to learn all the different types of adjuvants today, and I hope that you'll understand their different purposes so you'll know which ones to pick. And the other thing that's a little frustrating is some products may already have adjuvants in the formulation and some don't, but the manufacturer rarely tells you whether there's something in the jug already or not. So it makes this decision of whether or not to add an adjuvant a little bit more difficult when you're using these products. And then the other thing that we need to consider is our water. Water we use to make our spray applications, but we know that water pH is variable depending on where you're pulling your water from and what location you are in the country. And we also know there's other characteristics of water besides pH that are variable. A big one is water hardness, and that one doesn't get very much thought by most golf course superintendents, but it's a big influencer on particularly herbicide applications. And then there's other less common things that we won't really get into today that can affect, that are characteristics of our water that can affect the application, but they're more rare instances. So we're mainly going to talk about pH and water hardness today as far as how water quality influences our application. There's two publications that we're going to make available to you as handouts today. I'm going to show both those to you today, and then I'll have a few other handouts that we'll provide as well that I'll reference here in a bit. The first one is this one on the impact of water quality on pesticide performance. So you can download this as a PDF from the handout section. And that one is a good one to just give you a good overview of what is water quality and how does it influence my pesticide performance. Again, you can download these all as PDFs, and there's also a link on your screen there if you want to order a hard copy of these. I think they're about $6 each, and plus shipping, and you can order those from Purdue's extension store. But the PDF is free. And then a second one, of which a lot of our content today is based on, is this one. It's called Adjuvants and the Power of the Spray Droplet. And this publication really has two halves. It has a first half that gives you more detail about spray water, and then the second half goes into depth on these adjuvants. And this is a publication that I co-authored with Fred Whitford at Purdue University, and a really extensive publication on this topic to give you some more background information. So it'd be a good resource for you to have when you're trying to remember the difference between all the types of adjuvants. So the first thing I want us to consider today is spray water pH. And the reason we should talk about pH because it affects what we call the half-life of our pesticides. That's how long do they last in the spray tank. And because they can be degraded by particularly high pH water. We want to talk about pH because it affects solubility of what we're adding to the tank. It affects certain tank mixes that we might do, and it also affects something called dissociation or splitting apart of herbicide molecules, which can reduce their efficacy under certain conditions. So those are the four reasons why pH has actually a big impact on your applications. Now, just to give you a couple examples on the first topic, half-life. And these are all available in published reports. And I do want to caution, I'll explain these in a little bit more detail, but we do know that pesticides, some pesticides, not all pesticides, but some pesticides are subject to this, what we call alkaline hydrolysis, meaning they break down more quickly in your spray tank when your pH is high. And so that's why, golf course superintendents and sales persons will recommend adding some kind of buffer to your spray tank to reduce the pH so this won't occur. And if you look at these examples on the screen, we'll just pick out the top one for sake of time. We got a product called Dilox there that superintendents might use for rescue grub control. And it says that at a pH of 9, within 30 minutes, half of the product might break down. Well, that seems pretty scary because there's no way you can mix the product and get it all sprayed in 30 minutes. And so, again, that scary information will rightly so cause a superintendent to want to buffer their water by or change the pH of their water so that it's lower, so they're not subject to this rapid breakdown. But the confusion is, does it really break down as rapidly as what it says? And the answer is no. And the reason is because this rapid breakdown only occurs to the part of the molecule that's soluble. And without getting into too much of a lengthy explanation of this, basically when most of the things we would add to our spray tank are not completely soluble. And so part of what you add will be solubilized, and the rest of it would be just suspended, floating around in your spray tank. And that's why we agitate our spray tank, so those materials stay suspended and evenly mixed in the water. And this alkaline hydrolysis only happens to the part of the molecule that's solubilized, because that's the only part that the pH can affect, is a soluble part. It can't affect the part that's suspended and not yet in a soluble fraction. So to give you an example, 7, which carbaryl, common insecticide, has a half-life of 3.2 hours at a pH of 9. But its solubility is such that when you add it to the spray tank, you're actually adding it to the spray tank at 250 times its solubility index. And so what that means is that the half-life is only occurring on 1 part out of the 250 parts that you've added to the tank. And so it's still something to be concerned about. It's still something we might consider buffering our water about, but it's not something that's quite as scary as some of the facts may make it seem. So I want us to kind of keep this in mind. There's a lot unknown about this, but we do have some information on the raw ingredients that tells us that they can be broken down at a high pH, but also tells us that that based on the rates we're adding them to the tank, we don't anticipate in most normal conditions that if you sprayed these at a high pH, you'd actually notice any decreased control. It's only under abnormal conditions where maybe you mix something up and you don't get it sprayed right away, or maybe you're spraying really low rates of a particular product, or maybe your pH is even higher than 9. It's only under those conditions that I'm most concerned about pH. And like the previous slide showed, and I kind of skipped through, is that in all these situations, pH is not really going to be a factor if we can mix and spray in a relatively short amount of time. I might call that 4 hours. You know, if I can mix a product up and get it sprayed on my golf course within 4 hours, I shouldn't worry about the pH breaking down my whatever ingredient I'm adding to the spray tank. Now, another thing that pH can affect is different tank mixes. And this is kind of a rare thing, but it can affect different tank mixes. And this might just be like a color difference. And so, for example, here's a product called Secure, relatively new fungicide. And you see I've mixed it in 3 different jars there at the label rate. And the jar on the left has a pH of 5, the one in the middle has a neutral pH, and the one on the right has an alkaline pH of 9. And you see that they're almost the same color, with the one on the right being a little more peach colored. But what's really interesting is if I tank mix Secure with the Heritage TL, then these colors really get dramatically different. And here's an example of how the pH of your water will dramatically affect the color of the fungicides that you add to the tank. And so here, when we have a high pH, this mixture is going to turn kind of an orange-red color in your tank, and it may just really catch you off guard, because all of a sudden this color change is going to occur, and you're maybe reticent to if the product even works or not. And based on our discussions with the manufacturer of these products, that they've done some research to show that the product works regardless of what color it is, but the color change at least tells us that there's some kind of chemical reaction that's occurring in the tank that the pH is influencing. And so pH can definitely influence these products that we're adding to the tank. So we need to pay attention to it. Again, in this example, Wouldn't be necessary for you to change the pH, although I might prefer a less dramatic color in my spray tank. So I might buffer my water just for sake of mind, but again, no data showing that in this example that the efficacy of the product would be changed. Now, pH also affects the splitting apart of herbicide molecules, and so when a pH is high, certain herbicides, what we call weak acid herbicides, are more likely to split apart. And when they split apart and we use hard water, then that can cause a problem. And we're going to talk more about that in just a second when we talk about hard water. And then the last thing that I kind of glossed over is just this idea that because we don't have a lot of good examples in turf, but in ag, we have examples of how pH affects the solubility of products. And so there might be certain herbicides we would add to the tank that would not become solubilized and therefore might not work as well under certain pHs. And to date, we don't really have too many of these or one of these that we clearly know in turf. So that's good news. But that's just something to consider as well, that pH can affect the solubility of what we add to the tank. So if I'm a superintendent, how do I prevent pH problems in my spray tank water? One is if naturally your pH of your water is 7 or less, then you're probably not going to have too many issues. And there's only a couple products on the market that might specify that they would prefer a higher pH. Most products work pretty well in a range of about 5 to 7 on the pH scale. So if your waters that you pull from are naturally less than 7, then you won't have any problems. But most of you will probably pull from water that's above 7. In Indiana, most of our water will be between about 7.5 and probably 8.6, somewhere in that range. And so we're often dealing with high pH water, as I know many of you are as well. And if your pH of your water is high, in some cases, lowering it will help the product to work a little bit better. So let's kind of walk through some of these cases. And as I mentioned earlier, in all cases, if pH is something that can affect the product from an alkaline hydrolysis standpoint, mixing and spraying quickly will reduce the likelihood of any problem. But occasionally pH affects other things that aren't related to hydrolysis, and so we need to consider those cases as well. So every product is different, and sometimes finding the product as far as what's the optimum pH of these different products that we spray is very difficult. And so there's a couple charts out there, and these are some files that are provided for you in your handout section as well. Here's one from Winfield, and what they've done is they've listed all the common ingredients that might be in the products we use in the turf grass industry. If they have an optimum pH, they'll put that in, although they have this filled out for every chemical, and I can tell you that for most chemicals we don't know. So I think in their case, if they didn't know or there was no clear data on the pH preference, they just put in a neutral pH. And then they have this color-coded chart where you can go to the top, kind of find out where is my pH, and then look at the colors associated with the products you use and decide, is it possible that my pesticide might degrade under these conditions, or do I have a green light and I don't need to worry about this type of thing. So here's one chart that's available from a adjuvant manufacturer. Here's another chart, slightly different information. This one's from Precision Labs, also in your handout list. And this one lists the products and their trade names, and the optimum pH when it's known, should you use a buffer or not. In this case, a buffer is something that would lower the pH of the water. And then they put in there any data that's available on the half-life of the products we use in the turf grass industry. And for many, you'll see they just say stable over a wide pH range. And so that means it really doesn't matter which pH is, this product's going to work well in those conditions. So just like I said, most products that we use work well on a wide range of pH, so there's really no reason for you to be concerned with what I would say is probably 85% of the products you might use. But there are that 15 to 20% of the products that will have some specific language related to pH that you need to consider when you're mixing those up. So what I've done is I provided you kind of what my take is on this whole issue. And I've created my own tables, which are similar to theirs, but I didn't look at their tables for the answer. I studied the literature on all these products and the chemical information available to kind of create my own recommendation on these products. And it also includes any kind of label information that the manufacturer might provide. So you can download this. It's just a draft publication. I'm working on a more formal final version of it still. But I've got tables in there for the herbicides, insecticides, fungicides, and PGRs that we use in turf, and how pH and water hardness, something lacking in those other publications, may or may not affect the performance of the products you're using. So I encourage you to download that handout number 5 there, as that will be helpful for you to figure out, just quickly discern which products do I use at my golf course, and is there anything related to pH or water hardness that I need to be taking into consideration when I mix these products. Now, again, I mentioned earlier that sometimes the manufacturers include an adjuvant in the formulation. They don't tell you about it, and that's kind of frustrating as a scientist, you know, when you ask me questions about these products, and I just don't know that much about what's in the formulation, because that's a protected via their patent. But we do know that some products will have something in them to affect the pH. Most don't, but some do. So, so I'll give you a couple examples of this. So here I've mixed some different herbicides that are used in the turf industry on the left. I mix them with well water. I measure the pH, and then before I added the herbicide, and then the pH after I added the herbicide, and you'll see that Roundup Pro, the Monsanto formulation, has an acidifying agent or a buffering agent in the formulation that will reduce the pH of your water. And that's because this particular product works better at a low pH. And rather than giving you some instruction about adding a buffering agent to your water, the manufacturer has just chosen to include that in the spray mixture. I can tell you that all the other products listed on this screen also would work maybe a little bit better at a lower pH under certain conditions, but those manufacturers have chosen not to add anything and not to give you any instructions about the pH. And I would tell you, all these products on the screen, I'm more concerned about water hardness than I am the pH. But again, you can see one product has something in the jug to change the pH, the others don't. What about the fungicides? If we take a look at some of the fungicides that we might use on a golf course, I've got a list of them there. In this case, I mix them with some tap water. There's the pH of the tap water, 7.3. And if we add the fungicide, you'll see one of them, Clary's 3336. The pH of the water drops down quite a bit. And the others basically have no change. It's a marginal change within just a 0.1 or 0.2 pH units. But with Clary's 3336, the pH changed quite a bit. Why was that? Well, we can get a little bit of insight from the label. And here's the some snippets from the label. That's why it's always good to read the label. And it says to us right here, the pH, let me get my underline tool here. It says here that the buffering of tank water to a pH of 6 to 7 prior to adding the fungicide is recommended. And so they're giving you a clue that this product works better at a low pH. And another clue that you have in here is, if you keep reading, it says don't mix with certain materials, including alkaline pesticides. So they don't want you to put anything in the tank like alkaline pesticides such as a Bordeaux mixture or lime that would cause the pH of the water to increase, because they're telling you that the pH that this product works best in is 6 to 7. So even though they give you those instructions, they understand that you're probably not going to read the label, and so they went ahead and put something in the formulation to drive your water pH into this range that works best for this particular product. So if we have some kind of a water pH issue, often it's that we have too high of a pH. We can use an adjuvant to correct our pH issues. And so let's define first what an adjuvant is. So an adjuvant is defined as something that does one of these three things. It improves the biological activity of the pesticide, so it makes it work better, or it modifies the water droplet or the spray pattern so that the product works better, or it enhances the handling characteristic of the spray solution. So like on this last bullet, a good example would be a defoamer. So if an adjuvant does one of these three things, then, or if a product does one of these three things, we call it an adjuvant. And we have really two types of adjuvants. We have let me back up. Some people like to classify these two adjuvants as one of these two things. And I'm just going to introduce these to you. I personally don't like these terms, but they're used. So if you hear them, you'll know a little bit about what they mean. So there's two types of adjuvants, one called activators and the other called utility adjuvants. And the activators enhance the product performance, often a herbicide, but doesn't necessarily have to be a herbicide. And utility adjuvants change the conditions, often the conditions in the water or of the spray droplet, so that the product will work better, will be a little bit more useful. Now, activators, common examples of those are surfactants, which non-ionic surfactants are the most common, or oils, which are sometimes also called penetrants. Utility adjuvants would be, these others that we have listed here. And we're actually gonna talk about each one of these things. So I like to just kind of look at all of them in one big list. And so the first three, the first group that we're going to talk about are these three. The first two are similar but different. We have pH adjusters. Those are ones that will lower the pH of a water often. Sometimes they're called acidifying agents. The second group are called buffering agents, and what distinguishes them from the first group is that the buffering agents will change the water pH, but also they include other ingredients that help the water to resist further change. So the advantage of a buffering agent is you can add them, get your pH where you want it, and then when you continue to add more products to the tank, the pH should stay at about that same level. It shouldn't change. Whereas with the acidifying agents, if you add an acidifying agent and then you add an alkaline product next, then the pH will change and become more neutral, and it might change from where you want it to be. And then the third one in that red box there are water conditioning agents, and these are adjuvants specific to water hardness applications. Now, whenever you're using a pH adjuster or a buffering agent, okay, almost always they lower pH because the most common condition is to have too high of a pH. But if for some reason, if you have very acidic water, just note that there's very few products on the market that are made that will raise the pH. There are a few, and if you're looking for one, I can help you find one. But most of the products you would buy at the same places you would buy your other products from the same vendors, they are geared towards lowering the pH of the water. And when you look on the containers for these products, you're going to see, these terms. Acidifier is one good one, or here's another one, acidifier. It's going to basically, these products are really good in that on the label they tell you what their function is. And so here we have one that just says pH adjuster. They're going to tell you what the function is, so you don't need to look through the list of ingredients and try to figure out what the product does. They just tell you in big letters, what the different adjuvants do. And so what you want to do is look at the label and figure out what specific type of adjuvant is recommended on the label and use that one. So there's 10 or so different adjuvants. I want to look at the label and figure out which one does the label recommend. So let's look at some label examples here. The first label we look at is Monument, and you'll see it talks about if the pH of water is less than 5.5, you need to raise the pH with something called a buffering solution. So I'm going to look for some kind of a buffering agent to raise the pH with this particular product. If I'm using Revolver, similar note, it tells us that pH near 7 is ideal, and if the pH is less than 6, add a buffer. Here's Quicksilver. It says that the ideal spray solution is 6 to 7. So depending on if you're above or below that, you should adjust the pH of the solution with a buffer. Here's the label we already looked at. Again, it says buffering the tank water. So they're most commonly wanting you to use some kind of what they call a buffering agent to get the pH to the desired range and to hold it there. Now, one note on these buffering agents, before I show you a couple other labels, is that I would add just a little bit at a time and continue to measure the pH in my water after adding a little bit. It will come in with some directions that says, you know, add a pint of this or a quart of this, but it's highly dependent on what your water is starting off with. So test your water pH and then add a little bit of these at a time in order to figure out, you know, is my pH in the desired range right now? Here's another example. This is from a Canadian label for a product called Roverol, which we would know as, you know, either generic Iprodion or 26GT in the US, same ingredient. And it's got a note in here on a couple things is that if the spray mixture should be, the spray mixture should be used as soon as possible on the same day, especially if the water used is alkaline or has a pH greater than 7. And that's because this is one of those products that's subject to breaking down under high pH conditions. If you look at the US label for the same ingredient, it doesn't say anything about the pH. It just says, don't allow the spray mixture to stand longer for 12 hours as breakdown may occur. Here's 7 insecticide. The language is kind of tall, but it basically says the water pH should be 7.0 or less. That's ideal. And we need to use a buffer if the pH is above 8.0. And then the last example I have is Scimitar. Scimitar is an insecticide that has a language that says that you want to use a buffering agent to get the pH between 5 and 7 for it to work best. Now, there's a question from Kevin that asks, well, would adding pesticides raise the pH or of a, assuming he means of a low pH water? The answer is it's completely dependent on the pesticide. Most pesticides will be more likely to lower the pH. And so a couple examples, we've already shown you an example of Roundup, I believe Proxy, PGR, and I believe Signature. All those products will lower the pH of the water quite a bit. So some of the products that we add to the tank will change the pH. Most will lower it. Some may increase the pH. There will be no information at all on the label that will tell you one way or the other which way the pH of your water is going to change after adding these products. So the only way you know is to test the pH of your water before and after adding the product to get an idea of what's the optimum pH, because ultimately you guys are tank mixing several different products together in the same tank, and if one product prefers a high pH and one product prefers a low pH, then that's telling you that one, maybe I shouldn't mix these two things together, and two, if you're going to mix multiple things together in the spray tank, it's always a good idea to know, do any of these dramatically change the pH of my water? And if so, do they move the pH of my water outside of a range of what the label says works best for my product? And again, there's limited information out there about that. And the only way you know is to test the products that you use. There's probably about, I don't know, 15 products that you use most commonly on your golf course. And so just test, what does my water do before and after adding these products that I most commonly use? And that'll give you a good idea of what products may or may not work best for tank mixes and so on, based on what the label recommended pH is. All right, now just a note on mixing order, that if we want to adjust the pH of the water, that's always what we recommend doing first. And that's typically what the label will tell you to do. So Summary of pH. It's only an issue for a handful of products. Most products we use will work just fine, regardless of your spray water, but some products may need some manipulation of the water to work their very best. And in the cases of products that may break down in high pH water, if you mix and spray them quickly, you shouldn't have any issues at all with those products. It's only if you would mix and let the product sit in the tank for an extended amount of time that those products would not work quite as well with that second application. All right, so now let's talk about water hardness. And water hardness is just a measure of calcium and magnesium and iron in the water. And when we measure water hardness, it's always going to be reported in some kind of a calcium carbonate equivalence. And usually the units that are used are parts per million, or sometimes you'll see this in metric, written as milligrams per liter. But that's what we're measuring is calcium, magnesium, and iron, the most common things we're measuring in those water sources. And if we have very little of them in our water source, we call them soft. And if we have a lot, we call them very hard. And there's a couple of different scales that are used out there. I'm not really concerned about the scales so much. Just realize that if I don't have calcium, magnesium, and iron in my water, I have soft water. If I have calcium, magnesium, and iron in my water, I do have hard water. And most commonly, we have a lot of areas that have very hard water. Here's a map just of well water in the United States. And you can see certain pockets where the white and the red colors are, we have a lot of issues with water hardness. So the majority of the state of Florida, the Midwest, the Plains states, and even some areas out west. If you live on the East Coast or in the Northwest, you're less likely to have issues with water hardness, but it doesn't mean that you locally don't have hard water, because water quality will vary considerably from one source to the next. Again, most of the time, whether using a well or stream, river, or municipal water, they're all classified as hard. And it may not make sense why municipal water is hard, but just trust me, it is. It's based on some things they do to help maintain the longevity of the pipe infrastructure in your hometown. But rainwater is soft. It's the only one that's soft. And so you could, in theory, collect, if you had hard water issues, you could collect rainwater off the roof of your building and use that to spray your herbicides, and that would solve the problem of water hardness. And I actually know one lawn care company that does that very thing. We can measure both water pH and water hardness using test strips, and this is what I recommend. I recommend these two particular brands of test strips just because I bought and purchased them and they work well. For pH, I also recommend getting a handheld pH meter. They usually run about $100 or so. And the reason we want a pH meter for pH is because some of the things that we add to our spray tank are colored. And so if they have a color or dye in them or a pigment, then that kind of renders these test strips useless at telling you what the pH of the water is. So recommend getting a test strip that will test both hardness and pH, and that's common and pretty easy to find. And again, here's one I recommend from this brand called Hawk, and it works well. Now, if you measure your water hardness, you might have a simple question of, well, how hard does my water have to be to cause a problem? And the problem that the herbicides can cause a problem with the most often is your glyphosate. This is the product that's most easily antagonized by hard water. So anytime you're spraying glyphosate on your golf course, whether it be, some weeds that are growing up in the cracks on the sidewalk or under a fence row or as part of a renovation, you need to consider, what is my water hardness, and do I need to condition my water? That's the fancy term that we like to use. Condition my water to reduce the water hardness. And I would strongly encourage you to do that with glyphosate. Now, we've been doing quite a bit of research with 2,4-D, And what we find with 2,4-D is that it can be antagonized. Only the amine formulation is antagonized, and that occurs at levels of 400 parts per million or higher. So you could have a situation where your water was hard enough to antagonize glyphosate, but was not hard enough to antagonize 2,4-D. The good news is when our water is antagonized by hard water, it's very easy to correct. I'm going to teach you how to do that in just a second. One important point to remember is that water hardness does not cause a problem with fungicides or insecticides. Okay, so that's good news. When you spray fungicides or insecticides, you don't need to worry about water hardness. Water hardness only causes a problem with herbicides, and when it does, it happens immediately. That's also important to remember. So unlike with the breakdown of fungicides and insecticides, you can't just mix a herbicide with hard water and then go spray it quickly so that the problem doesn't occur, because the herbicide will be antagonized immediately by the hard water. And in our tests, we've sprayed within 20 seconds of mixing and we still get antagonism. So there's no way you can spray it fast enough for that antagonism not to occur if you have hard water. And so how does hard water antagonize herbicides? Well, it's fairly simple. You just have to think about some magnets in order to figure out how it works. We have hard water cations in our water, and they all have a +2 charge: calcium, magnesium, and iron. We have a herbicide molecule down here like glyphosate, for example, and they have a single negative charge. So what happens is one calcium molecule, since it has a +2 charge, can bind 2 glyphosate molecules in the water, and so that creates a big bulky molecule that doesn't work very well as a herbicide. And just to show you what that looks like, on the left here we have, in the middle we have an untreated weed. On the left we have glyphosate, a low-rated glyphosate sprayed in deionized water, so water that's clean of those cations. And then on the right we have glyphosate sprayed in well water that was hard, and we see the weed is much bigger there. And so what's going on is that those calcium, magnesium, and iron molecules in that well water are antagonizing the herbicide, and so it's just not working as well as if it would have if it was sprayed in clean water. So that's the problem that hard water causes. The solution is simple and inexpensive, and that is ammonium sulfate. We want to add sprayable ammonium sulfate to our tanks when we're spraying certain herbicides to remedy the hard water problem. And this is how it works. So ammonium sulfate will have a double negative charge on the sulfate and 2 single positive charges on the ammonium. So that's how it makes a nice neutral molecule there. And when we add that to our spray tank that has the glyphosate and the hard water cations in the tank, the sulfate with the double negative charge will bind to the calcium and the magnesium with the double positive charge. And then the single positive ammonium ion will bind to the single negative glyphosate ion. And it creates an ammonium salt of glyphosate, which will work perfectly as a herbicide. Now, a lot of the glyphosate labels will tell you this. They've got a special section on ammonium sulfate where they say add 1 to 2% dry ammonium sulfate by weight, which is equal to these numbers, which are the important numbers for you to remember, that you want to add somewhere between 8.5 and 17 pounds of ammonium sulfate per every 100 gallons of water. And if you add those, that will improve the performance of the product under hard water conditions. Now, these numbers here are kind of confusing. Where in the world do they get 8.5? Where in the world do they get 17? Because over here they say 1 to 2%. Well, it just has to do with the fact that water, 100 gallons of water weighs 834 pounds. 834 pounds times by 2% is going to be 16.7, or nicely rounded, 17 pounds. And so that's where that number comes from. Now you can buy ammonium sulfate again as a spray grade ammonium sulfate. It's a 2100 fertilizer, but when we add it at the rates that we use as an adjuvant for a herbicide, it delivers a very small amount of nitrogen. So it's not really fertilizing the weed. It's just adding a little bit of this ammonium sulfate to the spray tank that will help to allow the herbicide to work effectively. Now, if you don't want to buy the dry product, you could buy a liquid product that contains some kind of ammonium ion. Here's a picture of the dry product. It's spray grade ammonium sulfate, very inexpensive, about 60 cents to $2 an acre, depending on your spray volume. Or you could buy a liquid product, and when you buy a liquid product, you want to look for this term, water conditioning agent. So any product that is called a water conditioning agent will have ammonium sulfate or some kind of other ammonium ion in the list of ingredients, and that allows it to work to fix these hard water issues. Now you may say, well, I've got some urea in the spray barn. Won't that work as well? And the answer is no. You have to use an ammonium source of nitrogen, and ammonium sulfate is the most readily available for us in the turf industry. There's an ingredient called urea ammonium nitrate that's used in ag, or, back in the day we used to use ammonium nitrate. Both of those also work, but ammonium sulfate's the easiest for us to get our hands on, and so that's what we recommend. It's also very inexpensive, but urea will not work. Now, I showed you how glyphosate is antagonized by hard water, but 2,4-D is as well. Same thing happens. We have a negatively charged, actually this falls away, and that's where the negative charge occurs on the molecule. We have a negatively charged 2,4-D, a double positive calcium, and then so that produces one big bulky molecule that will not work well as a herbicide. The solution is to add ammonium sulfate. The ammonium will stick to the herbicide. The sulfate sticks to the calcium, and your herbicide works all of a sudden again. So here's a proof of this concept. Here we have a non-treated weed on the left. If I spray the weed with 2,4-D in hard water, you'll notice I have a very big, healthy weed. But if I spray the weed in hard water and I add ammonium sulfate, notice how the weed is much smaller. The root system is much more less developed. And so it's showing us that ammonium sulfate helps the herbicide to work the way it's supposed to. And we've done the research to show that this antagonism starts to occur around 400 parts per million. That's the part where the water gets so hard that the herbicide will no longer work as well. I mentioned this only occurs on amine formulations, not on esters. And so if you're using an ester, you don't have to worry about hard water antagonism. And the way that we know if it's an amine or not is simply by looking at the label. We're going to look for the suffix amine on the name of the ingredients. All right. Now, we've also done these tests, not as much, but done tests on three-way combinations. Like here we have 2,4-D, MCPP, and dicamba in hard water from calcium. And if we add ammonium sulfate, notice how much better the herbicide works to control the weed. If I have a four-way combination of herbicides and I add ammonium sulfate, not quite as dramatic of a picture here, but you can still see that adding the ammonium sulfate will help the herbicide to work the way it's intended. Now, despite all those great pictures I just showed you, only glyphosate labels and sethoxidin labels currently say anything about adding ammonium sulfate to the spray tank. 2,4-D, Trimec, none of those labels say anything about it. So this is new information that I'm providing to you that would encourage you to add 8.5 to 17 pounds of ammonium sulfate for every 100 gallons of water when you're spraying basically one of these broadleaf herbicides. One of those herbicides that was in that list of weak acid herbicides I showed a few slides back. There's also one PGR that is affected by hardness, and that is this new product called a new. And if you look at their label, here's the actual text of the label, and then I typed it out here below. But it says that if your water is greater than 40 parts per million, which I would tell you that almost all water is, they recommend adding a pound of ammonium sulfate for every pound of a new that you use in your spray tank. And that'll help to overcome the issues affected, the hard water issues that affect that particular product. Now, it's not just hard water that can antagonize your mixtures, your herbicide mixtures in particular. If you add iron sulfate to the spray tank, it will antagonize these products, Embark, glyphosate, MSMA, anything with 2,4-D in it. So be careful about mixing iron with those products because it will cause antagonism. And here's just a data slide to show that. We'll skip through that for the sake of time. Here's 2,4-D by itself. Here's what happens when I add 2,4-D with iron. Notice the weeds get bigger. We want the weeds to get smaller, but they get bigger because the iron is antagonizing the 2,4-D. So don't mix iron with your herbicide application is my recommendation. Not that you would, but you wouldn't ever want to mix a micronutrient package with your herbicide formulation either, because these micronutrient packages will cause excuse me, antagonism of the herbicide. So maybe you're out spraying the roughs in the fall and you got some extra micronutrient product and you think, well, I'll just throw that in the tank. It won't do any harm. It will actually do harm. The herbicide won't work nearly as well when you mix those products with it. Okay, so all those are water quality issues, but I want to get to some of the other adjuvants that we're going to talk about first. And let's see if we can answer Eric's question before we move on. It says here, for buffering pH and need to add ammonium sulfate, which would you do first? I would add the ammonium sulfate first, Eric. It will lower pH about half a unit. So what you'll find is you might not have to add as much buffering agent to the tank if you add the ammonium sulfate first. Generally, otherwise it wouldn't matter, but I think it'll just save you some buffering agent if you add the ammonium sulfate first, if you're adding both to the tank. All right, the next three I want to talk about are surfactants, oil concentrates, which are sometimes called penetrants, and humectants. Okay. So whenever we spray some kind of product on the leaf and we want that product to get inside the leaf, we know that the product has to go across this lipid membrane that's on the leaf surface. So we're going to spray the product over the top. The product's going to move through the cell wall slowly until it reaches some kind of equilibrium. And all of this movement is dependent on the product being in solution. And so it follows the water. The product will follow in the water through the cell membrane. And so the product has to be wet or in solution in order for this movement to be occurring. And so one of the ways we can enhance this uptake is the use of surface active agents, also called surfactants. And you can see based on the underline there where that word comes from. So I've got a video here, and I don't know if it'll work well for you. So it's a short video, so hopefully it'll work. It just shows that when we put a spray drop, oh, it didn't work. That's all right. We'll just skip through these videos here. So what these surfactants do is they help that water droplet spread out over the leaf. The reason that that's a good thing is it increases the leaf area that the droplet is over and helps to allow more of the product to penetrate that leaf cuticle and get inside the plant. And there are many labels that will encourage you to add these surfactants. So here's one with Quicksilver. Adding surface active agents or surfactants may improve the efficacy or effectiveness of Quicksilver. So if you're spraying for weeds or for moss control, they're encouraging you to add a surfactant. And the most common ones that we would use, we call non-ionic surfactants, or we often will commonly abbreviate them as NIS. And so you want to look for a product, and right on the jug, it's going to tell you what you want to look for. Look for this non-ionic surfactant, and that's what you need. Now, many of these products will come with multiple ingredients. This one has an anti-foaming agent and a non-ionic surfactant. Those two are commonly paired together because the non-ionic surfactant is kind of a soap-like substance and can cause some suds to form in your tank when you're agitating it. But you really only need the non-ionic surfactant. So the anti-foaming agent is in there just really to help you with your mixing characteristics. It's not in there to help the product work any better. All right, now some labels give very specific instructions on what to use. Here's the Sledgehammer label. It says use a non-ionic surfactant, and it says that the product must contain at least 80% active material. And so when you're looking at a product, let's say I want to use this one, it says it's a non-ionic low foam wetter spreader adjuvant. Okay, so that's a non-ionic surfactant. If I zoom into the product, though, I notice that it says it only has 70% surfactant in there, and the Sledgehammer label said that it needed to be 80%. Now, could you use this product with Sledgehammer? Would it still work? Yes. It's just the manufacturer of Sledgehammer, in this case Gowan, has said we think our product will work even better if you use a higher surfactant content product. Now, some products will not call for a surfactant. Instead, they'll call for an oil. And there's two types of oils. There's a crop oil, and there's what's called a vegetable oil, or often called a methylated seed oil. Now, the crop oil, even though it's got the word crop in it, is actually a petroleum-based oil. So it just has the word crop in it because you're spraying it on a crop. So crop oils are petroleum-based. And so whenever the product calls for a crop oil concentrate, you want to use it. If it calls for a methylated seed oil, you want to use that one. Or in this case, the product says use a non-ionic surfactant and do not use a crop oil concentrate. And the reason is because in this case, the crop oils have been shown not to work as well with this particular product. So again, a crop oil is going to say right on the jug if you want one, and often the ones that are petroleum based will be some kind of a paraffin oil constituent will be their main ingredient. So some products, instead of calling for a non-ionic surfactant, they do specify a crop oil concentrate or a methylated seed oil. And a good example of this is the new product called Pylex. Says add a crop oil concentrate or a methylated seed oil. It says that doesn't recommend using a non-ionic surfactant. It doesn't prohibit you from using it. It doesn't recommend it though. So they have some internal data that says that these oils work better with this particular product. So it's something to keep in mind. If it's a methylated seed oil, those products are actually plant-based or vegetable oil-based products. They're usually a little bit more expensive, but they are considered to work better in some circumstances. And the main reason they're more expensive is just they're harder to make, more expensive to make. But sometimes a label might specify this over crop oil because of, again, some internal data that the company has that suggests it might work a little better. So a good example of this is Drive. It specifies using an MSO, and it says only use a crop oil concentrate if you don't have access to the methylated seed oil. So again, look at the label to see which one it recommends. And why are we using these? Again, because they help the product to work better. Often it's just a little bit better. So here's some of our crabgrass control data at Purdue. We used a product called Square One, which contained quinclorac, and did a pretty good job reducing crabgrass from about 60% down to 20%. But if I added a non-ionic surfactant to this particular mixture, you'll see it reduce crabgrass another 10%. So adding the surfactant, if the label calls you to, which this product does, is definitely worth doing because you'll get better control. Now, some products may tell you do not use a surfactant. The use of surfactants is not recommended with this dismiss herbicide, and every herbicide is different. In this case, this product works very quickly on its own, and so you don't really need a surfactant to help the product work better. All right, now how much do I add to the tank? A good rule of thumb is that whenever I'm using a non-ionic surfactant, I want to add about a quart for every 100 gallons of water, and that's equal to 0.25% on a volume by volume basis. So that's the recommended rate that's most commonly used for surfactants. For crop oils, it's usually 1% volume by volume. So in that previous example, it would be like 4 quarts in 100 gallons, or the manufacturer may just simply state 1 quart per acre. So you can follow either one, just both would work if the manufacturer gave you both options. Now, a note I have on here is that since the crop oil concentrate dissolves the waxy coating on the leaves and allows the product to get in the leaf better, they also can cause some injury to plants under high temperature conditions. So if you were making a spray in the summertime and you had the option to either use a non-ionic surfactant or a oil-based product, a methylated seed oil or crop oil, in the summer months, you'd always want to go with a non-ionic surfactant because it's less likely to injure your turf when you make that application. In the cooler parts of the year, the crop oils would be fine and will not injure the turf, but in the summer months they can under those hot conditions. All right, and we're rounding out the last few slides here. I want to define the last 4 adjuvants, and those are stickers, drift control or deposition aids, defoamers, and compatibility agents. A sticker is something that improves the retention of the droplet on the leaf. And so that's both it helps the droplet not to bounce off the leaf when you spray it, but also it helps the droplet not to be washed off the leaf. So if you were making an application in maybe like a rainy season, but you needed to get the herbicide out, it was one that's say like a contact fungicide that needs to coat the leaf well, then it might be good to include a sticker in the tank, and that might help less of that fungicide from getting washed off the leaf. However, many liquid products may already have a sticker in the formulation. And so sometimes you know that, sometimes you don't. And if you use a non-ionic surfactant, that also will often act like a sticker. There are also anti-drift agents out there, sometimes called a more PC term for those is deposition aid. And basically they're polymers that increase the viscosity of or the thickness of the solution. I personally don't recommend using these, and I would much rather you just change your nozzles if you're worried about drift. And it's much easier just to change those nozzles or to lower the spray pressure in order to reduce the risk of drift. And I'm not going to cover defoamers because I think you know what those are. So the last type of adjuvant is called a compatibility agent. These are ones typically used when you make very concentrated mixtures of herbicides. So the lawn care industry uses these more commonly when they're using the ride-on sprayers and spreaders. But it helps to ensure more uniform mixing of particularly fertilizers and emulsifiable concentrate type products. Incompatibility is usually not a real common problem in the golf industry. So I don't think you'll probably need to run into these very often. But in certain products, it is an issue, again, especially when you're mixing fertilizers and herbicides together. So If you're not having these issues, if you're not having any issues with your products mixing up well, then there's really no reason for a compatibility agent. All right, finally, some tips on buying adjuvants, because unlike pesticides, which are governed by the EPA, adjuvants are not. So you want to make sure you're buying a good quality adjuvant. So I'm going to give you 4 tips here to look for. And if you, I would say find 2 out of the 4 of these, then you can be assured that you're buying a good quality product. Okay. The first one is to look about how much of the product is an actual functioning as an adjuvant. So in this example, we have 90% of the product being an ingredient, okay, but only 70% is classified as the surfactant. Now, I personally think this is a high quality product. I use this in my research. I'm just using it as an example to point out that you want to look at the label to figure out what portion of the adjuvant is actually functioning as the adjuvant, as in this case, a surfactant. All right, the second thing you can look for is some kind of a California or Washington registration number. In California and Washington, they have a special registration process for adjuvants that other states do not have. So when you find that registration on a label, that ensures you that the product has went through a more rigorous quality control and examination by those state regulators, and that you can be buying a high quality product. The third thing you want to look for is some kind of a sun shaped stamp. And this stamp is given by a group called the Council of Producers and Distributors of Agrotechnology. Basically, it's a bunch of manufacturers that have banded together, and they certify each other's products when they meet high quality standards. And so when you look on the jug of a product, you'll see this little stamp on the jug, and that's telling you that you have a high quality product. So if you find any 2 of those 4, any of the, I've given you 3 so far, find any of those, you know it's a good quality product. And the last thing to look for is something called the CFR 40,80. And it stands for a particular law that governs that certain adjuvants are legal to apply on food crops. So when you look on the label and you see a CFR 40-80, you know that that product is actually safe to spray on something that someone else is going to eat at a later date. So we figure if it's okay for people to eat it, then it's okay for you to spray it on your golf course. Now, beware of any adjuvants that just kind of have outrageous claims. So maybe they claim that you can use reduced pesticide rates if you add their adjuvant, or that also be careful of what I call cocktails. These would be when they put 4 or 5 different things in an adjuvant and it does all these magical things. Often you just need one of these things, so I wouldn't recommend these mixtures. And of course, anything that sounds too good to be true often is. So just be aware of the claims made on for these products. Remember that some products may already have an adjuvant in the tank, in the manufactured product. And for example, Roundup does. It actually tells you on the label that it contains a surfactant, and you don't need to add one. Another example is Daconil Ultrix has this weather stick technology, and if you go on their website, they tell you what is that, and it tells you that their product contains an adjuvant that allows it to basically stick to the leaf better. So these are examples of products that already have the adjuvant in there. And anytime you're using a product like, let's say, Daconil, that you want to coat the leaf well, it makes sense to include an adjuvant. In this case, the adjuvant's already in there. But what also makes sense is just to make sure you're using the right nozzles. And even though this isn't a nozzle talk, just a reminder that if I use nozzles like the ones here at the bottom that give me good coverage of the leaf, that's going to translate to better control. And there's published research that shows this, that when I use smaller droplet size so I get better coverage on the leaf, I'll have less disease. So just keep that in mind. The adjuvants are important, but nozzles are just as equally important. Now, what if there's nothing on the label anywhere about using the adjuvant? What should I do? First, understand all the different types of adjuvants and what each one does. Understand any pros and cons associated with using those adjuvants. Thirdly, know your product chemistry and whether or not an adjuvant may or may not help it. And then do your own little experiment. Take an area on your chipping green or an area where you apply 90% of what's in the tank, you add a little bit of adjuvant, and you spray out the last 10% and see if it worked any better than the areas you've already sprayed, and that will help be a good test. So, in conclusion, water impacts the performance of our products. We don't have all this figured out yet, basically, and so we're still trying to learn all the possible combinations and figure out what works best. Some labels warn us, many do not, and checking the pH and hardness of our products is worth the money considering all the other costs with our applications. Often we need to adjust or condition our water to maximize the efficacy, and adjuvants are a helpful tool in maximizing the efficacy of these products, and they're inexpensive compared to the cost of the rest of the products that we use. So with that, that covers all my slides. I do have a couple quick ads. I have a handy 128-page multi-state publication on weed control. If you need good advice on what products work best on what weeds, how to control your troublesome weeds, I encourage you to get a copy of this. It's available for $20. I co-authored a book with Dr. Nick Christians that came out last fall. So I encourage you to consider that. And we have a new app out at Purdue. It's mainly targeted at the lawn care audience, but we're hoping to revise it for the golf audience here soon. So if you'd like to use apps on your phone, that'd be something worth checking out. It's just $1.99. And with that, I'll let you know that I made all these slides available as a handout. And here's all my contact information. So feel free to shoot me an email if you got questions as a follow-up to today's presentation, and be happy to help you out.
Thanks, Dr. Patton. I've loaded all of the handouts into the system, so hopefully everybody has access to those. If there are any other questions, we'll hang around for a little bit. And a reminder, our next webinar is on fairy ring control on July 6th, and that's going to be with Dr. Mike Fidanza, and also one on July 10th on summer stress with Frank Rossi. So please check back with us for those as well. If anybody is unable to access those handouts, just shoot me an email after this is over, and I'll make sure you get everything you need, and just shot that out through the chat. So hopefully, though, everybody can pick those off as you need them. So if there are no other questions, we'll take one last look here. Speak now or forever hold your peace. Dr. Patton, thanks so much for putting this together and sharing it with us. This has been backstory on this webinar today. Has been a long time in the making. I think it was at the OTF show back in December when we first talked about this, and it's taken us half a year to actually get our schedules together here. So appreciate your patience with that. And if there are no other questions, we'll see you next time, and hope everybody has a great day.